Dear students, in this small video session, we'll try to see some questions on frequency modulation. Let us see the first question. You can read the question. A sinusoidal carrier of 20 volts and 2 megahertz is frequency modulated by a sinusoidal message signal of 10 volts and 50 kilohertz. And deviation constant, frequency deviation constant, or we can call it as a proportionality constant, Kf is equal to 25 kilohertz per volts. You have to find out delta F, which is called as maximum frequency deviation, beta, which is called as modulation index, and bandwidth and power. Repeat the above if message signal is amplitude is doubled. Suppose if the amplitude of the message signal is doubled, calculate again maximum frequency deviation delta F, beta, bandwidth and power. Let us see how to do this question. First of all, you check what is given. The amplitude of the carrier signal is given 20 volts. Frequency of the carrier signal is given, Fc is given 2 megahertz. And amplitude of the message signal, which is also called as modulating signal, is given. Similarly, frequency of the message signal or modulating signal is given. Similarly, Kf is given. You need to remember some formulas over here. Now all these are given. AC is given, Fc is given, AM is given, FM is given, Kf is given. Very well you know your delta F is going to be Kf into AM, right? Your delta F, the maximum frequency deviation, is equal to Kf into AM. So you get it as Kf into AM, which is 25 into 10, right? So it is divided by Fm. Fm is actually given as 50 kilohertz, right? See, it is 25 kilohertz per volts, and AM is 10 volts, and your Fm is 50 kilohertz. The kilohertz get cancels, and also similarly volts get cancels, and you will get your beta value as a 5. Anything above beta value very high, above 1, right? We call that frequency modulation as a wideband frequency modulation, right? Similarly, the bandwidth, the value is equal to 2 times beta plus 1. It is actually 2 times delta F. Same thing can be written in terms of beta and Fm. So it is 2 into, okay, so beta plus 1 is, it is 6 into Fm, you are going to get 600 kilohertz. Okay. Similarly, power. We all know the power of a frequency modulated wave is equal to AC square by 2, which is equal to 400 by 2, because AC is given is 20 square is 400 by 2, 200 watts. Now the second part of this question, which is part B, it says that, okay, it says that repeat the above if message signal amplitude is doubled. Suppose if this is doubled, if it is 20 volts, use that specification and try to solve the problem. Same formula, everything is same. You get, see what's happening. Your delta F remains same, okay, and you can see that beta is getting doubled, and similarly bandwidth also is getting doubled, but power remains same. So what is the changes going to happen here is, when the message amplitude is doubled, both delta F and beta will also be doubled. You can see delta F will now, earlier it was actually something Kf in 25 into 250, right? Now it is 500, right? Similarly, beta is, earlier it was 5 and now it is 10, right? So this is a solution for this problem, and we will see the other question in the next video. try to practice these questions. Remember these formulas which are very much helpful to you.